All right,
Ooh, wow. That's amazing.
there we go. So, um, why don't we all get rolling? Um, Hello to everybody. Thank you for being here. Apologies for the little delay, but everybody rolls into meetings a few minutes late, right? Um, my name is Joe Castiglione. I'm the executive director of the Zephyr Foundation, and I really want to thank you all so much for being here for today's Zephyr learning session on GMNS, or the network, General Model Network Specification. Let me share my screen. All right, can you all see that?
Yes.
Yes.
Great.
Well,
Uh, did I lose you? Did I lose you?
yeah,
Oh,
you lost the screen share.
That was weird. Okay, let's try take two. All right, how about that?
yes.
Wonderful. Uh, Thanks again for being here. Before we jump into today's session, I just want to go over some basic ground rules. First, participation in the webinar requires compliance with the Zephyr Member Code of Conflict, which is basically just be nice to each other. I'm sure we won't have any problems. Uh, you will have the opportunity to put questions into the chat box, and then our moderators will then forward them to our speaker, Scott. If for some reason you do have any, please email the address you see here, admin@zephyrtransport.org, and we will be as responsive as we can, hopefully pretty quickly. Note that we are recording the session, so if you decide to share your likeness on the screen, it is with the tacit acknowledgement that you're allowing us to kind of record and distribute it. Um, Before we get into any of the rest of today's, and I'm going to maybe pause this and stop sharing. Excuse me. Stop share. Before we get into anything, I first want to uh, take a moment to ask you to complete a brief survey. Um, and the purpose of this is really just to kind of assess your familiarity with different data standards and what you think actually might be useful from the learning sessions that we are going to be offering this year. And so, if you'll just bear with me for a moment. All right. And are you able to see the poll?
I see it.
Okay, wonderful. I'm going to continue while you guys are working on that. Oops. I want to talk to you a little bit about some of the other learning sessions that we have coming up, because this is the first about 7 sessions that we're going to be doing over the next 6 months. Um, you can see all these great sessions that we've assembled on the screen. You can also find them on the Zephyr website at zephyrtransport.org/events. And we hope you'll join us for these subsequent events as well. 4 of these sessions are going to be focused on network data standards, on multimodal accessibility measures, network assignment and data tools, and then finally capping it all off with a session on the Network Wrangler tool. That's 4 of them. The other 3 are going to be focused on highlights from the 2025 Modeling Mobility Conference. And I'm really pleased to kind of announce, many of you probably already know this, that we have already scheduled the 2027 Modeling Mobility Conference. It's going to be held in April of 2027 at Arizona State. We want to give a shout out to Brian and Zena and Peter and all of the dedicated volunteers who are already working to put this together. We hope you'll join us for that. The 2025 conference was really great. We also want to thank Doctors Shusong Zhu and Ram Pindyala for helping facilitate that. And with that, I'm going to hand it over to Lisa Zorn, who's going to do some kind of stage setting. And I'm also going to close down the poll right now. Thanks so much.
Ooh, thank you, Joe. All right. Just a little tiny bit of background, but not too much. GMNS is being developed as a data format specification for modeling networks to help facilitate seamless integration of tools and ideas in travel modeling and in adjacent fields. So basically, GMNS is for modeling networks, what GTFS has been for public transit routes and schedules at a high level, but you'll hear a lot more of that in a few minutes, and so I won't go further into that. But I do want to say if you're interested in joining the discussion on this, so if any of this is interesting to you particularly and you want to continue discussion on this offline, there is a Zephyr activity page, which I'll put in the chat right here. And we have a Google group for discussion. So you can reach out to me about that, about joining that. And so without further ado, I'm going to introduce our speaker and we'll get into it. So Dr. Scott Smith is a senior level operations research analyst with over 25 years of experience in applying technology to improve transportation operations and safety across all nodes. At the Volpe Center, his project sponsors have included most of the modal administrations in the US DOT and local agencies. And before joining the Volpe Center, Dr. Smith worked in private industry and he holds a PhD in transportation systems from MIT. And then not joining us today, but also having worked very heavily in this project, I also want to introduce in absentia Ian Berg, who is a data scientist at the US DOT Volpe Center. His research portfolio involves transportation technologies ranging from e-bikes to automated trucks, and he also provides support to modernize US DOT systems and processes. He has degrees in mathematics and urban and regional planning, but unfortunately he's not joining us today, but we definitely want to acknowledge all of his contributions in supporting this work. So with that, I'll hand it over to Scott to get into to tell us about GMNS, what it is, what it was, how it was developed, and how it can be used.
Thank you, Lisa. Uh, can folks see my screen?
I can.
Yes.
Yes.
Okay. Alrighty. So I'll ask if we have quite a few people here, so people to mute themselves, I guess except for me, and then and throw questions and comments and the like into the chat. And of course, there's always time for conversation afterwards if we run out of time. So I'm going to introduce GMNS. So this came into being nearly 10 years ago. There was a Shark Tank type session at the 2017 Planning Applications Conference, where several ideas were proposed, and I think the one that won that Lisa had proposed was some sort of data standard for sharing networks. A common language, so you're not having to rebuild networks from scratch each time. Meanwhile, at the same time, Federal Highway Administration was wrapping up its Sharp 2 C10 projects on integrating dynamic traffic assignment and activity-based modeling. And those resulted in a few rather rich data sets, not just nodes and links, but going on into traffic controls and other details in the network. And the question we had was, well, how do we share this? And that was really the birth of GMNS, these two ideas coming together. And so we're really going for something that runs from micro modeling to very general macro modeling and a common language for sharing networks, kind of a reference specification that people can use. So again, that's a key feature of GMNS is that it bridges those levels of detail and modeling. Your starting point, of course, is nodes and links. It's simple. But then we can get into things like traffic controls, pocket lanes, uh, bike lane sidewalks, attributes that vary by time of day, all the things that are of more interest for operations analysis and doing dynamic traffic assignment and simulation. So that's the bridge that GMNS is trying to build. And what I'm going to do in most of this presentation is just quickly explain what it is. So on GitHub for more detail, and then talk just to a few of the use cases and how we've been using it in our work and a few others. So, so what do we mean by the examples of flexibility, like physical network elements on a map, static models, nodes and links? I think this crowd's pretty familiar with that. If you're getting into a more micro model, you may be caring about portions of a link, like a pocket lane, lanes. Uh, Connecting the links, well, at a micro level, you're concerned about movements within an intersection, like the difference between a right turn and a left turn. Uh, and then care about link capacity, intersection capacity, and all those other elements like speed and then pedestrian bicycle networks and traffic controls. Um, so again, I will go into details of how we bridge this gap. So here is the monster schema, uh, and it's really kind of serves as an outline for the rest of the presentation. Again, we start with nodes and links. Uh, that's the only thing that's required. And then typically, again, in the world of static modeling, you're going to care about zones, might be parcels, might be traffic analysis zones, uh, and you may be holding geometry separate from the node or link or as part of the node or link. That's okay. So again, that's the world of static modeling. But then you're going to start caring about, well, what's going on within a link? How many lanes are there? What are the characteristics of those lanes? Who's allowed to use them? Um, what's going on along the curb? What kind of pocket lanes do you have? And then finally, at intersections, what kind of movements are you allowing? Left turn, right turn, going through. So that's the next level. And then going one level further, you start dealing with traffic controls. Now, if it's stop or yield signs, it's fairly simple. Because anyone who's worked in traffic signals knows that traffic signals can become a lot more complicated. So have them as their own set of elements where you can deal with phasing and timing plans. If you have, again, it's not required, but if you need it, there's a place to put it. And then finally, the elements that vary by time of day, which can be just about anything. Like you might have a time of day use on a lane, like a parking lane that becomes a bus lane during morning rush hour, and so on, or different movements allowed at different times of day. So those are the elements, and then the next few slides are going to be drilling down into each of these areas in a little more detail, a few examples. So nodes and links, only required elements. Um, and for a node, you just need to know where it is. Then you can always optional fields. You have required fields. You have optional fields where these are the fields we think people will commonly want to use, like, what zone is the node located in? Uh, is there a traffic control? What's the general control type? Um, so on. And you can also always add optional fields, user-defined fields. And then for the links, again, start very simply, from and to node and what the identifier is for the link. And then optionally, yeah, you might want the street name, you might want the shape points for the geometry, and the things that help tell you what type of facility it is, what the really the functional class, the capacity, the speed, number of lanes, and the types of pedestrian and bike facilities you have along there. Uh, Directed links for vehicle travel, undirected for pedestrian travel. And I'll note that you can always have user-defined fields. For example, if you're drawing from a system with linear referencing, that's pretty easy to add. Um, Drilling down a bit further is talk about say within a link, what happens within a link, both along its length, where you might be adding pocket lanes and the like. So that's a segment. Says, what lanes are you adding here? What lanes are you adding for turn pockets? And then you can define lanes specifically, like say this, if you want to represent a bike lane within a link, you can have that just a separate lane, allowed use as bike, or you can have lanes, they're limited to buses or exclude trucks. Uh, Handle it that way, different lanes. And then moving on to the multimodal accommodation is, one general concept is we can always define points along a link, like for major land uses, bus stops, where you can tie into the GTFS stops model. An important field we found is, the allowed uses, like what is allowed to flow on this link? Is it just for walking? Is it for anybody? Uh, and even some non-travel uses. And then we include fields for parking, pedestrian facility, bike facility. So even if you are not representing a sidewalk as a separate link, just as an attribute of the main road link, well, you can do that. You just say allowed use is walk and pedestrian facility as a sidewalk, or else optionally you can treat the sidewalk as its own undirected link, adjacent to the road link, as is shown on this vertical example here. Of course, once you are handling, say, sidewalks or separated bike lanes via their own links, it may be useful to have a parent-child relationship. May want to know, well, what is the associated road with that sidewalk? Because it matters, like in the pedestrian environment, how much traffic that road has. So you associate the sidewalk of a road, and this becomes also important if you have, a bunch of pedestrian crosswalks and curb ramps, entry points into the crosswalk represented as their own nodes. You want to relate those nodes to the main node for the intersection, which the traffic signal is tied to. So you all know all those nodes are associated with the same traffic signal. Um, and so parent-child relationships become important and useful. Um, so the next three slides, I'll be going through a few more of these points with a multimodal example. It's a very interesting intersection right near my office, where we have certainly sidewalks and three types of bike facilities at one signalized intersection. So we find it useful as a demo. The east-west street here has, going has conventional bike lane. It's a divided road called Broadway. It has a conventional bike lane along the side, unseparated. So we said, all right, we're going to treat this as just have the general purpose lane with allowed use, including bicycle, and the bicycle facility as a bike lane. The sidewalks, those green lines, are treated as their own links. But then going north-south becomes a little more interesting. Coming in from the north, underneath those trees, are two off-road paths, one for bikes and one for pedestrians, coming into this intersection. And then coming up from the south, you have a two-way separated bike lane on the east side of the street, that's coming up from the south. So something like that, I'd recommend representing as its own link. Um, and then all this is associated with one traffic signal. So that's how he kind of represented, showing the flexibility in how you might represent things. Generally, I found if the facility is not physically separated, you might represent it as an attribute on the road. But if it is physically separated, like a curb or a barrier, you might want to represent it as its own links. So, continuing on this example, I want to talk a little bit about movements within an intersection, which static modeling don't really get into most of the time, but certainly important in operations modeling. So green lines are simply the various crosswalks And then for the bicycle and motor vehicle movements, I'm just showing the movements coming up from the south so that this picture does not become too cluttered. So you can see what's happening is motor vehicles coming from the south have two choices. They can turn right or they can turn left. Bicycles coming from the south can turn right, left, or continue on onto that path that's under the trees. So there's an object in GMNS to represent these movements. Uh, and in just doing that, you can just see on the picture right here where possible conflicts might occur. So if you're thinking about safety analysis, a useful thing. And so then we get into, so you may be wondering, well, what's the phasing and timing like at that traffic signal, given the complexity of this intersection? So And this, and so we actually had the report from the redesign of this intersection that happened 15 years ago. So yeah, you can represent the traffic signals, signal controller, uh, and then signal phases and how they are associated with movements within the intersection, which I think is the key thing for this business. And then once you have the signal phases, uh, you have the timing, signal timings, different timing plans by time of day. Again, the time of day stuff coming in here. Uh, and coordination of other signals, and then signal detectors. You might have traffic detectors, or you might have pedestrian push buttons, so another form of detection. All those can be represented, and you can see at the top of the screen here is the way the phasing on this works is first Broadway to East West Street goes, and then you have the left turns from Broadway on to the going to the south and the right turns at the same time. And then with the left turns coming from the street from the south, that's when the bikes go straight across. And you just see grammatically, this is how this particular intersection, City of Cambridge manages the conflicts. And all this can be represented. And all this is optional. So if you don't have if you're just getting started, you don't have signal data, not to worry. All this is optional. Um, so the next stop on this quick tour of GMNS will be the time of day elements. And so move to another example. This is a freeway that allows shoulder use of the breakdown lane during rush hour. Again, a very similar approach you might use for shoulder bus running. So what we have here are the four lanes numbered from left to right, 1, 2, 3, 4. And then most of the day, the left lane allows auto and bus. Uh, the lanes 2 and 3, the main travel lanes allow everything. And the lane number 4 is a shoulder, not used for travel. But then you can have a lane time of day, which will override that lane table during the PM peak time period. So that's lane 4, and you're saying, all right, we're going to allow auto and bus. It's basically implementing what's on this sign here. It says, travel and breakdown lane permitted 3 to 7 p.m., but no trucks. Uh, and then weekday, then elsewhere in the specification, you can define, well, what do we mean by weekday PM peak? Well, Monday through Friday, 3 to 7 p.m. So I'll mention the whole spec is on GitHub, and we'll send the link out, put the link in the chat at the end of the meeting. And it's all very extensible. So to summarize, within GMNS, we're trying to bridge that gap between static modeling, node link modeling, and more operational modeling. So again, have details on links of all types. We consider time varying networks. We consider what happens at intersections. little bit of very basic transit integration, which I won't talk about today. What is not explicitly in GMNS are traffic volumes. And recognize they're important. They also have their own time dimension. Uh, can handle it via supplemental tables. I think we just made a decision not to include that as part of the spec, but tying it in, I think it's very straightforward. The other thing, which I'll talk about more, a little bit more in one of the use cases, is the very detailed curb ramps, facility condition. Again, easily added as user-defined fields, and under the auspices of Bureau of Transportation Statistics, another specification has been developed within the last year, which really gets into that, and I'll point out where that is a little later. So now a few use cases. So if you get onto the GMNS website, you will notice that all the examples are pretty tiny using CSV files, uh, which is great for education, great as an entry point, maybe not so great for running a large scale network. And so, got this critique, which is fair at Modeling Mobility Conference. And wait a second, we're not requiring that. You can the representation can be anything you want, really. So coming out of a discussion at that conference, I did some experimenting, and it's not a requirement, but what I'm finding works pretty well, in the open source world is putting all the elements of GMNS into a spatial light database, which is the spatial extension of SQLite. Again, freely available. So one example, so generated the whole Boston area, roads, sidewalks, everything from OpenStreetMap, uh, put it in a spatial light database, and it's a pile of links, pile of nodes, so it's pretty efficient to load. So I would recommend doing something like that if you're going to work on this at large scale, encapsulate it in some sort of database structure, uh, and go on for there and be happy to talk further. Now, that. Um, Next thing I want to mention is you're doing details on accessibility. Uh, well, GMNS already has a lot of what was needed because it started from, we got to consider all travel modes, not just highway things. So we already considering pedestrian bike accommodation. We have the option for separate links. We know how to represent transit stops, and we know what to do with intersection controls. But as I mentioned, in the past year or so, under the auspices of Bureau of Transportation Statistics, they got a bunch of users together and really came up with this very detailed node link specification of active transportation infrastructure, uh, disability access, bike, pedestrian. So it was involved in that. It's informed GMNS a little. I think GMNS has informed Gatus a little. But if you're interested in the great detail at the node link level for these types of issues, take a look at it, and maybe someone can stick that link into the chat at some point, um, or just Google it, and you'll likely find it. Um, I quickly want to mention multi-resolution modeling because part of the motivation for GMNS was looking at, okay, here's a big gap. It was documented back in 2021 Federal Highway Report. Then a little later on, so mentioned the C10 motivation uh, for doing GMNS, and then Simon Joe was involved with a study, Northern Virginia Transportation Authority, using the GMNS network because they wanted to do multi-resolution. mention in our own work at Volpe, we're also making use of GMNS for various projects. And I think the overall issue is that often data is tied to specific applications. And that's something we want to get away from. We just want a common language for sharing the data around. And then the expectation is, well, if you have a specific application, a specific software, you'll have a very straightforward process to going into the language that software needs. Now, I've got experience with this. There are like tools to get from OpenStreetMap to GMNS, and then we have experience getting from GMNS network to the type of network that the Equilibre open source routing tool uses. It's something we use in one of our systems. So again, typical is, break things down into pieces so you're not trying to keep the data focused on the data and the applications focused on the applications. So finally, again, publishing consistent data, that's what we're trying to do. Bringing the planning data in with the operations data, first times is being tried. Uh, and kind of reducing the barriers to working with routable network data. Right? Now, I think we've got the tools now that any local community could build a routable network from openly available sources. And speaking of sources, obviously there's local data from your state DOT or MPO. Start filling in items. OpenStreetMap is a popular source. It's pretty good, again, but on the other hand, the completeness does vary by location. And derived applications might have some licensing issues. And then you've got the highway performance monitoring system world and AGIS, the federal highway world, um, where where here you can leverage state DOT investments in keeping their highway data up to date, the more authoritative data source. It's had some struggles with routing, but we're making sure GMNS can play nice with that. And I believe the newest version of the Aegis manual will be mentioning GMNS. It's a possible way to represent your networks. So to close my part of the presentation and leave a little bit of time for discussion is kind of takes a community. So I want to give a shout out to a few people, including those on the call. Uh, is Simon Joe for his students, his team developing all these tools to use GMNS. The developer of the Equilibre, Pedro Camargo, Elizabeth Saul, add Billy Charlton to the list for his thoughtful critiques, and and others. So, we're making use of it here. A few others have made use of it. And we just wanted to give folks an introduction and, solicit comments about, where do we go from here to be most useful? And at that is almost the end of my presentation. So the links, the names for our teams, and I think we'll try to get these into the chat during the Q&A. And our team at Volpe Center, I just want to also thank Federal Highway for supporting our contributions to this. They're interested in seeing it be successful. And with that, I'll stop. Stop.
Right. Woohoo. Thank you, Scott. And I think other folks will come on screen here and get this started. So we have a few things, and we have a Mentimeter poll that we would like to do now. And we'll also have discussion. So I'm gonna put the Mentimeter poll into the chat so people can get started on that. There it is. And then we've received some questions already, so we'll go through those first, and then we'll open it up, I think. And Joe, you were there too, so. Yeah, Yes. And I feel like who's doing what? I'm not sure. Joe, if you want to take, do you want to take care of questions or it's up? I have no idea. I feel like we we didn't decide this stuff ahead of time concretely, or maybe I didn't know. So Ooh, you're on mute.
You'd think I would learn. Lisa has dropped a bunch of questions into the shared doc that we've been working on. So that might be a good place to start. And I can kind of queue those up for you if you can't find them quickly. Um, are you able to find them? If not, I'll just read you the questions and you can respond.
Yeah, maybe do you want to just review the questions and then Scott can respond on the fly?
Sure, sure. So the first came from Will Alexander. He said, "What would a lane number 0 represent? Is that valid in the spec?"
Okay. Thanks, Will. Typically no. Is I'm viewing, we conceptually view lane number 0 as the center line. And the reason this becomes important is our convention is to start lane number 1 at the leftmost through lane. And what that means is if you have a left turn pocket that goes across the center line, it becomes lane number -1. Uh, so again, that's our convention. Uh, if something else is far better, we're always willing to listen. But that's our convention is lane number 1's the leftmost through lane.
All right. The second question came from Jim Bunch. He says, okay, so there are two different schema that are often used in current major travel demand models, a link and node structure with AB and BA links connected by nodes as used in Cube and GMNS, and a link ID-based structure with one link identified by its ID and a separate field for the BA and AB characteristics. But the nodes are not automatically posted on the networks used by Transcat and other simulation models. How does GMNS deal with the latter? Are there utilities to interface with Transcad and the like networks?
Um, yes, we have dealt with the latter. Uh, no utilities specific to Transcad yet. Um, but what we've done is, certainly I'm familiar with the issue of the link directionality. I think we concluded to go with the directional link route because when you end up actually flowing, actually sending the flow down the network, that's what happens internally. Uh, and so we've had to deal with this. It's been somewhat a little bit manual. I think Equilibre also has, the bidirectional links as you simply split them. And then you identify the nodes by where the links cross, and this is how it works. Like you're doing a conversion from OpenStreetMap, and maybe Simon can jump in. Uh, is that I think it also has a bidirectional representation. So what you have to do is identify the shape points on the two links that coincide to get your connection node, and hope no one put that at an overpass. Uh, and and then when you have attributes of the link in both the A and B directions, you simply have to split them for the directional links. Uh, we've done it right now, not super automated. If there's a real demand to automate that, I think it wouldn't be too hard.
All right. Another question now from John Glebe, who says, can links be attributed with slope or elevation change for bicycling? It's really important to know
Uh,
upslope direction and
yeah,
so.
went through it pretty quick, but grade is an element of the link. Yes.
Great. Okay.
Yeah.
Uh, Guy Rousseau asks, in terms of interoperability and integration, can data from GMNS be seamlessly imported into ArcGIS Pro or ArcGIS Network Analyst, converted into feature classes, and then built into network data sets for traffic assignment, static and or regional? And it seems like there's a theme of kind of interoperability.
Right. Uh, making a note to ourselves here. Um, Now, for first, if your internal representation of GMNS is something that plays not, so again, there are examples in GMNS, our little tiny CSV files. And as I work in the open source world, I like spatial light because that plays really nice with QGIS, the open source GIS. But you can encapsulate your GMNS network, say, as a set of shape files or maybe a geodatabase, something that plays nice with ArcGIS would be my recommendation. If you're an ArcGIS shop, figure out, geodatabase, whatever storage mechanism plays nice with ArcGIS, and then you should be in business.
All right. Another question now
Well,
from Taylor.
actually, and let me add a real quick thing because I think that's
Yeah,
really interesting. Like
yeah,
this presentation has been focused on GMNS, but the Zephyr activity is on like standards and tools. And so
yeah,
I think this goes to the whole concept of like a standard or a specification is often more useful when you have tools that go along with it. And so
right,
the subsequent learning sessions will be on the tools.
right.
So I think we'll get and like it's a little awkward because different people are working on these different pieces. So I
Yeah,
think that's a lot of like what we're trying to do here is bring these projects together and like marry them more because they really kind of all belong together. So
right.
just a quick aside.
Yeah. Well, what I'm hearing here is figure out how to, because a lot of shops really are working with ArcGIS, so I'm making a note to look into that some more.
And then again, to reiterate
Yeah,
Lisa's point, on August 20th, we're going to be having another learning session that is explicitly
yeah.
focused on these sort of supporting tools. Should we keep rolling through questions? All right. Taylor Reich says, where can I learn more about the public transport integration in GMNS or about experiences of using GMNS and GTFS together?
Um, a lot of that came from the Northern Virginia project, and we have, all right, I just, we have a public transport representation in one of our other projects that touches on GMNS. I probably want to send a note offline on that because it might be kind of hard to find. So who asked the question? Who's
This is Taylor Reich, and we can connect you with
Yeah, we
his.
can tell. Yeah. So it's a very basic representation of transit that we've used in Norfolk, Virginia. Simon has used it in Northern Virginia. So we can point you to those studies of how we've done it. And it's really the tool that Simon's team has built to really to get a node link transit network that's compatible with GMNS off of GTFS data. It's a pretty neat tool that his team has built. Uh, so GTFS, I think I'm going to stick it in the chat if I get this right to GMNS. Oops, I can't even type it. Yeah.
All right. The next question comes from Steve. He says, I see HPMS, Arnold, and AEGIST were mentioned. Has there been any effort to formally map, I don't know whether it's said MIRE or MIRE
Mo
fundamental
mo
data?
Model inventory of road elements. Yeah.
Okay.
Model. Uh, Internally, yes, not published it yet because these things are changing, but we are actively working with Federal Highway to be aware of what the latest is on those efforts of HPMS and to develop a mapping.
All right, great.
Yeah.
Next question from Raj Roy. How does GMNS generate centroids and centroid connectors, and can users change or customize these?
GMNS has space for zones, and centroid connectors can certainly, now GMNS is all about the data, so it doesn't by itself generate centroid connectors. Although believe there is a tool that has been developed. There have been some tools developed to do this, where you input a set of zones and you first locate the centroids, and then you generate the connectors. I've done it using tools within a GIS, and they make the centroid connectors part of your GMNS network. And I do believe some other tools exist for that, but I would view this generation as part of the supporting tools.
And
All right.
I'll unmute really quick to say
Yeah,
it's that this is an interesting conversation and it touches on
yeah.
um, so, the last learning session is on Network Wrangler. That's the one in October. And
Mhm.
in Network Wrangler, and this is related to the previous question around GTFS also. In Network Wrangler, we've been working on that to specifically be focused on, like a static assignment model network.
Mhm.
And so GMNS has more of a like a wide focus, and Network Wrangler has a narrower focus of the static assignment model network. And so the GTFS integration directly onto the network and the Centroid connector generation, well, actually, that one has not been, I'm still arguing that I think that that belongs in the Network Wrangler library of tools. But anyway, I think there's this interesting discussion of like, on the tool set side, what belongs in the tool set and what's kind of out of scope. So anyway, so just that'll definitely come up in that session.
All right, cool. Next question. I want to apologize if I mispronounce this gentleman's last name. Marcos Zenuk says different models have different link and node attributes. Does GMNS allow different link attributes? Does it have a flexible metadata?
Absolutely. So you're really, in terms of attributes, I view them as three categories. One is the required attributes, like, and then for the link, it's going to be the link ID and the from and to node, which if you're drawing from Transcad, you have to generate. Uh, then you have the other attributes, which we think people are going to want to use a lot, like the like geometry, its length, its speed, functional class, stuff like that. But then, within the specification is you can do whatever you want on user-defined fields. So extend it as much as you want. And of course, as anyone who's worked in this business knows, um, it's a balancing act. You could make it so open, but then it's kind of, well, then why bother with a specification at all? Or you make it so restrictive, no one can use it. So we're trying to, meet that balance of a little bit of flexibility, and then kind of, if we find that everyone is using the same user-defined field, then all right, let's maybe make that really part of the specification sort of thing. Or if no one is using one of the standard fields, we'll maybe demote it. Just remove it as a standard field.
Right. Great. We have a couple more questions from Robert Farley. It seems like this may be most useful for those with bespoke or commercial network packages looking to expand into, and the question says DTS. I'm wondering if it means DTA.
DTA, yeah.
What other use cases do you see for adding GMNS coding and formatting to our network maintenance?
Uh, well, I think one use case is, say you're bringing networks together from a number of agencies who use different software stacks. And, what's the common language? Well, I think we're trying to offer a common language here. Like someone on a cube network and someone else on a Transcat network, and you're trying to bring those networks together.
Right.
So I think that's really, it's really about the share, or the use case that was just mentioned. If you're starting from a planning network and then you want to get more details into it, this offers a pathway.
Sure. Or possibly even for people, transitioning amongst different
Yeah.
commercial areas as well.
Yep.
This is the last question it seems we have in the chat, and then I think maybe are we going to share Mentimeter results as well? Or I'm not sure if that was part of the
Yeah,
plan.
Yeah, that I
yeah, we
was
should.
asking, I think so.
Okay,
Right.
the last
Yeah.
question is from Chetan Joshi.
Yeah.
It may be worth mentioning that the schema is meant to enable, and this gets to what we were just talking about, to enable interfacing. And any tools really should be built by by users who are using the schema as a reference. So maybe you can speak to the question about the toolkit that you'd like to see or the tools built around the standard.
Sure. Maybe Simon can jump in because he gets credit for developing many of the tools. Um, so what we see, in our own work is, yes, we'd like to see tools say, one thing that exists already is the OpenStreetMap to GMNS, and then GTFS to GMNS. This is like for building the network. We've developed a few validation tools to say, do you have a basic network? And one of, and then our RDR tool suite is, okay, so you built a network, you think it's valid, then you want to route on it. So we're fairly experienced with, several open source routing tools, including Equilibre. Uh, and so we're familiar with that path. So, and that's helpful. Hey, if you want to see if this network's actually connected, just run a bunch of shortest paths on it, and that will tell you something. Uh, and and so
Yeah,
so limited. I think that there's yeah, jump in, please. Yeah,
yeah, Scott. Yeah. So based on my years of the learning experience
yeah,
using GMS, I
yeah,
would like to point out a number of other tools which will be very useful.
yeah,
Dashboard,
yeah,
visualization. Once you
yeah,
have all the network really in the standard format, you can connect your there's another UTDF for traffic signals,
mhm,
TMC for rates in information. So you could really connect multiple layers of information into your wonderful customized dashboard. Particularly once we have AI, you can build your own dashboard. Okay.
yeah,
The second one will be accessibility analysis, and using the GTFS, GMS, you could have multimodal transfer,
mm,
schedule integration, and those will be the second. Third one will be optimization simulation because they have another two categories of community. They use Sumo, they use and other optimization tools. Once they can consume the network attributes from our planning
mhm,
community, those tools will become very useful for you to exchange information and really serving as a user in a broader community setup. Yeah, so that was my take. Thank you.
Oh, great. So I see Farid has raised his hand. So we probably have time for, or may have time for one additional question. And was there an intent to share the Mentimeter results, or will we distribute those later?
oh,
All right. So do you want to quickly walk us through these?
Yeah, so it looks like we have some 30 to 40 responses. Interesting.
mhm,
And this one has a quite a variety. Actually, there's quite a variety of responses. No distinction yet. And one thing I was requesting when I saw this one is that there are other distinctions between general traffic lanes and like HOV, access restricted lanes and price lanes. And so I think all of those are an interesting
mhm,
question in terms of how are they handled. And
mhm.
I think static assignment has some constraints, but with a broader audience, there's obviously more variety. Interesting. So we're still very much in the commercial vendors space, but there's also still quite a variety. One academic tool. All right, and we have a lot of travel maulers in the room, looks like. Nice. Quite a lot of variety there. Not a lot of route optimization. Oh, interesting.
Mm.
So the biggest one here being we do not do this. So that's still in progress. So maybe we should ask this same question again a year after the final learning session and see how the conversion rate looks.
Although I'd also note a lot of people, it looks like, have bespoke
Yeah,
in
in-house converters,
Yeah.
I mean,
which
one of
again is kind of my point is like, how similar are those? Are we doing the same things over and
Yeah.
over again?
Hmm.
That's
yeah,
a
and in
really good
general, I think that's something that Zephyr as an organization would really like to help agencies and practitioners finds opportunities to not reinvent the wheel,
yes,
and to have and promote common tools that are going to be useful broadly across our entire domain.
absolutely.
Well, we're almost at time. Farid, why don't I unmute you? And if you have an additional question, um,
The person has to unmute himself,
oh
but you
yeah.
have to allow it.
So I will see. There we go. Everybody has now been asked to unmute, and they should all be unmuted.
Pandemonium. No, I'm just kidding.
No, no, people have to unmute
I know, I
themselves, but now they can. Yeah.
know.
So, all right, free for all. Free for all. Uh,
Oh, I
We're
see the
all
question
very
also
well
in the chat.
behaved.
Will the recording be made available later on? And the answer is yes. All of the recordings from all of
yeah.
the learning sessions that we're doing, both this year and in past years, are available through the Zephyr website. We'll have them posted certainly within the next day or so. If you don't see it later today, it'll almost certainly be up shortly thereafter. Um, we're a little bit over time. I really want to thank everybody, first and foremost, Scott, for your great presentation and for all your work advancing GMNS, to Lisa, to Shusang, to everybody. So many thanks to you. And please come back and tune in again for our future learning sessions on this topic.
Hey,
Woohoo!
Okay.
great.
Thank you
Thanks.
all.
Thank you
Thank
all.
you.
Thank you.